we need to invest more in this because this is the thing that is going to unlock precision oncology at scale and precision medicine in other therapeutic areas as well. And it also becomes a no-brainer that we need to collaborate because it's such a huge opportunity that I don't think one company can tackle it all. And I actually feel like the companies that are positioning themselves right now are more allies than anything, in the sense that we're kind of pushing the adoption of digital pathology at large and really showing the impact that this can have on patients.
Welcome to the People of Pathology podcast. I'm Dennis Strank. On this podcast, we explore pathology, laboratory medicine, and forensic science. You may have heard about the recently announced partnership between Owkin and Proscia, aiming to streamline MSI testing for colorectal cancer. Today, my guests are Dr. Meriem Sefta, Chief Diagnostics Officer at Owkin, and Amanda Coble, Senior Director of Product at Proscia. We'll discuss the founding and history of Owkin. We'll talk about the partnership with Proscia and how these AI advancements can improve patient outcomes. All right, here are Dr. Meriem Sefta and Amanda Coble. Let's get some of the history of Owkin. So can you tell me about what inspired the founding of this company?
So I joined Owkin in 2017. I think they had been incorporated maybe for 6 months. So I wasn't there at founding, but very close to founding. And the company was built around the idea that basically biomedicine in general and just the medicine and biology is too complex for the human brain to understand and grasp and learn how to help in case of diseases alone. And so the idea was to say, we're going to access data from real world hospital settings and see to what extent we can apply deep learning AI to better understand patients, their outcomes, and in particular in oncology. And from that, so that was a kind of a general thinking of, where we wanted the company to go. And progressively, we realized that something that was largely underanalyzed in that hospital setting of all the data sources was pathology images, because pathology was starting to go digital, but was not entirely routinely digitized. And from a research perspective, very little had been done in the analysis of digital pathology images. On top of that, digital pathology images are so large and contain so much information that deep learning was particularly well adapted to analyze these images, and kind of more traditional data analytic methods from the past were not as much. And so we saw this opportunity between the fact that this data was going digital, the fact that it was particularly well analyzable by deep learning methods, and the fact that it's central in cancer care for kind of investing R&D in that space. And we kind of explored how we could leverage digital pathology and AI for biomarker discovery and better understanding of patient subgroups, but also patient testing and like routine diagnostics that we could then implement in the real world.
Okay, question about something you said. You said learning was particularly adaptable for pathology images rather than traditional methods. Can you explain that a little bit more?
Correct. Yeah. So, and I'm not the data science, expert here, but in a nutshell, in 2017, there were data analysis methods on images. The challenge about analyzing images through any type of method is you can only work off of numbers ultimately, and you can't actually calculate images. And so you need to transform images into numbers one way or another. The first step in any kind of pathology image analysis project in terms of R&D on our side is transforming those images into numbers. And back then, the way that researchers had done this without using deep learning is to create kind of human-based features that they derive from the images. So they're going to count the number of cells with a particular characteristic, measure the amount of tumor versus non-tumor in the slide, measure the number of blood vessels in the slide, and from that derive a whole bunch of metrics from the image and run their calculations and their analysis on that. But what we saw is that in that phase of kind of determining human based features, you're losing a lot of information because
Hmm.
the image is so rich that basically boiling it down to a few cherry picked metrics makes you lose some of the precision and some of the wealth of information that is contained in there. If I can make an analogy, it's like you're looking at the tropical rainforest and you have all these animals, all these trees, all these different species and what you're looking at. And you're supposed to say, okay, how do I transform this into numbers? And so you're going to say, I'm going to count the number of trees. And I'm going to count the number of birds. And then but you're not going to capture all the information. You're not going to be able to capture how green some trees are and how, some are lighter green or how tall they are or how they intermesh one with the other or where the birds are situated on the trees. And all of that information is kind of what you lose when you take a very complex and rich image and transform it into metrics that you've picked out yourself as a human being. And those first methods had started to be developed in digital pathology, but were also very nascent. And then came in, deep learning. Deep learning had just started to, show how powerful it could be on traditional images like the ones that Google and Facebook process every day. And so then the idea was to say, well, can we adapt these methods on pathology images and progressively use these kind of AI based methods on pathology images? And our thesis at Owkin was always to work in a called weakly supervised way, which is to say we input the entire image into the AI and we train our models on the entire image. So we try as much as possible not to lose any information and to kind of let the AI figure it out and figure out what exactly it needs to pick up on in the image and what are the relevant features. And so it's a completely different way of doing things where we're not actually making any hypotheses as to what is the relevant thing that we need to be looking at in the image. Is it the trees? Is it the birds? We don't know. We just input the entire image and kind of let the AI progressively, as it's being trained, figure out what are the important signals that it needs to pick up on.
Okay, I like that. The rainforest analogy. That's very helpful. So then, what became the mission of Owkin? Can you explain that?
So the mission then evolves to a very kind of precision focused mission, which is the right treatment for every patient. It's a mix of work that we do on drug discovery and development and how to use our AI methods to improve and de risk the drug discovery and development process. But also, once drugs are on the market or nearing the market, how do we best identify the patients that are most likely to benefit from them? And that's kind of like the precision testing part of our business, which is the part that I lead.
Okay, I see. All right, and we're going to get into a little bit later of not all of the products that Owkin offers, but some of them. But first, I'm curious, like what makes the field of digital pathology kind of a natural fit for utilizing AI?
Several things. One, it's the wealth of information. So one digitized slide contains ballpark about 2 gigabytes of data. That's as
Oh,
much as
wow.
a feature film. So it's an enormous amount of data that's actually contained in these images. And so, deep learning feeds off of data and complex, unstructured data. And so this was particularly a good topic to work on. The second is when you're looking at a pathology slide, you're really kind of looking at the tumor directly into its morphology, into like basically its makeup. You're staring at it like right in the face. And you have a level of information that you don't necessarily have at a genetic level, because at a genetic level, you're not going to see the cell structures, how the cells interact, et cetera. But you're at a finer level and at a better understanding that if you were looking at a kind of the radiology level, which is a little bit more kind of macroscopic. And so I think that for everything that has to do with really understanding these tissues, what makes them run, why some patients or some tumors will respond versus others, why some drugs work better on some patients versus others. This level of information, the pathology slide, is really, really critical. And that is why actually, except for some rare exceptions, virtually no patient is ever diagnosed as having a cancer without this image being generated and analyzed. It is the gold standard in terms of diagnosing and identifying cancer. And the idea is basically to say, well, we've been using these images mostly for the initial diagnosis, but there's so much information there that thanks to deep learning and AI, we can better extract all the information that's in these images and go further than just saying, it's a tumor. We're going to say it's a tumor and it's very likely to be hearing this targetable alteration and it's at a high risk of relapse. And we think that, you should run this additional test or put this patient on this clinical trial based off of the information that is in this image.
Yeah, I'd agree that pathology, I think people traditionally think of as it's a diagnosis, right? It's more of a diagnostic. But really, over the last couple of decades, we've seen, particularly with IHCs, it's become more of a prognostic piece. So first there's a diagnosis, then we need to look at, okay, what are the therapies that are going to work best? And again, the human eye has a limitation on what it can see on a slide. And we found more recently the low HER2, it responds differently. That extra level of granularity and maybe that deep insight that is beyond a human eye, what a pathologist can see, can be unlocked with AI. So it's that data rich, as Meriem said, slide that we are producing that's, for decades, they've been sitting on a shelf. Yeah, I use the analogy that sort of like a USB thumb drive or an SD card. Like if you had a closet full of those, it's all this information, but if you don't have the reader, like a USB driver, like to read it, or an SD card reader, doesn't do you any good. And we're just now with the digital pathology adoption, basically opening up that closet and being able to get that data off those cards. That's sort of how I describe it to my, non-technical or non-medical folks, which they seem to like resonate. Oh, that makes sense. You have all this data, but you can't get to it until you digitize it. So,
yeah, it's amazing when you think about like the decades and decades of slides that still exist, and it's all that data still on there.
Right. But it's largely, so a human eye can go look at it, can go pull it, but there are all these deeper insights that are in that pixel data, the 2 gigabytes, as we were saying, that, we don't even know what we don't know yet, honestly. What are the things sort of in the rainforest that we don't even know to look for yet?
Right.
So.
Okay. Yeah, that makes sense. And now I want to get into some of the products that Owkin offers. And at first, you've got a group of biomarker screening type products. And for example, MSIntuit CRC for colorectal cancer. Can you give us an overview of these biomarker products?
Yeah, with pleasure. So basically, the first kind of generation of drugs in precision oncology, some of these are blockbusters such as like Keytruda or Lynparza. Those drugs were very, very successful because they made some very smart bets, which is to say, we're going to develop drugs that are kind of fit for purpose, and we're not going to target all a patient population with them, but we're going to choose a particular population that has characteristics that make them particularly good responders to our drug. And that kind of guarantees or minimizes the risk of trial failure, and it gets your drug a lot of traction because when it works, it really, really does work. So that was the success of this first generation of blockbuster precision oncology drugs. And a lot of these precision oncology drugs relied on basically traditional precision testing methods. So either NGS, so next generation sequencing, to measure a certain number of mutations or alterations in patients to determine whether or not they could be good candidates for the therapy. Or the other large family of tests was basically visual pathology image analysis. So you run an immunohistochemistry and you're going to ask a pathologist, well, can you quantify what's the percentage of cells that are expressing this biomarker? And if it's above X percent, then, then the patient is a good candidate for the therapy. And both of these families of tests have some limits. For NGS, it basically you require biosample. frozen sample extraction of DNA or RNA, running kind of sophisticated tests in specialized labs. So your turnaround time is going to be relatively high, and you're going to have important costs related to running these tests because there's just like the overall process to getting the results is quite long. And in some cases, I would say the sensitivity and specificity of these tests versus actual response to treatment is not optimal. And then you have visual pathology image analysis. And here the issue is these images are so large, and what we're asking pathologists to do is more and more precise, that it's created kind of like these bottlenecks with pathologists that have to do like some like very quantitative things on these images, but in a very manual and just purely visual way. So you're looking at the rainforest, and I'm asking you, how many trees are under 20 meters high? And you have to look at the image, and you have trees in all directions, medium ones, small ones, large ones, and you have to guesstimate how many are under 20 meters tall. And the issue here is that then you have inter-observer variability. One pathologist will say, I see 10%. The other one will say, I see 15%. The other one will say, I see 30%, because it's a task that's very hard to do for a human eye on such a large image. And so the opportunity of digital pathology AI for example, biomarker screening is to enable pathologists to use that first image and use AI applied to that first image to basically pre-identify patients that are most likely to be carrying, for example, a certain biomarker. And that kind of relieves the pain of having to test everybody. So, for example, the BRCA mutation is actually only tested in about 50% of breast cancer patients today. So we know that actually 50% of patients are not being tested. And so it's critical to be able to screen more patients and faster. And what we've developed is basically AI that from that, initial diagnostic slide can directly determine whether the patient is negative, and there's no point in wasting time, energy, money, samples in testing that patient, or on the contrary, a very high chance that the patient is in fact a BRCA mutated patient, and basically encourage further confirmatory testing on those patients.
Let me make sure I understand this. So you're saying, because as you were talking, I was thinking like, how do you prevent sort of over testing, I guess, of these things? And it sounds like you do that, like from the AI can tell if you need to do additional testing for, like you just said, BRCA. Am I understanding this right?
Yeah, correct. So basically, the advantage of digital pathology AI tests is that it's just software. So it's very easy to run. You can run like very quickly on all the samples that you want. And then from there, you filter out the ones that are relevant for subsequent testing, basically.
Okay, I like it. That's definitely a big benefit for patients. So let's compare the MSIntuit to current testing techniques, things like IHC, immunofluorescence. How does it compare?
So MSIntuit in the latest version can rule out about 70% of patients directly from the pathology slide. So basically from the initial diagnostic slide, I can give you definitive test results on 70% of patients without having to do any additional testing, and without basically spending time, resources, biosample to get that result. So in basically half an hour of software processing time, I can get you that result.
Wow, that's really impressive.
I have to say that, I mean, having been someone who packaged these up and would send out, we didn't do the MSI IC in house. I would spend 30 minutes just packaging it up. And then there would be the cost and the, logistics, the turnaround. So like for me, just that 30 minutes where there's no additional packaging or costs, like it's just the software piece, like that is such a benefit. And not just to the pathologist, but also to the lab staff, which we know there's a lot of shortages right now.
Right.
So that one less thing that would have been on my plate as someone in the lab who was responsible for helping with send outs and things like that.
Okay, so not only the time saving, but the cost too. I like it.
And it's also kind of the scalability, because MSI is probably one of the first precision oncology biomarkers that was broadly tested thanks to the fact that it was associated to Keytruda. But now if you look at the pipeline of pharma partners, you have more and more precision therapies that are coming on the market. And so the need to test patients is only increasing. So you're going to be testing more and more biomarkers, more and more subgroups on more and more patients. So the combination of all these biomarkers is going to explode. And so the idea is to say the potential of this technology is to basically make this possible at scale, the rollout of precision oncology at scale. If you stay with traditional testing methods, there's only so far you can go because you're limited in amount of time, technician, actual biosamples. Sometimes you have patients that can't get tested because you run out of physical sample to test on versus, for example, this is software, so you can run as many virtual tests as you want. And so there's really the promise of breaking any last barriers that precision oncology has for scaling really broadly throughout the kind of oncology patient population. And I think that this is, looking forward, the most promising thing of this technology is that it just has all the features of something that can be broadly scaled.
This is the People of Pathology podcast with our guests, Dr. Meriem Sefta and Amanda Coble. We'll be right back. Are you thinking about applying to a pathologist assistance program and feeling a little lost? That's why I created the Path to Path A, your PA school application blueprint. This is a step-by-step prep course that gives you everything you need for a strong application. From finding shadowing to writing a standout personal statement to prepping for interviews, this course was made to help you feel informed, confident, and ready. Visit www.thepathtopatha.com to join the mailing list. You'll be the first to hear when the course launches. Your path starts here. LabVine is an interactive online learning platform where laboratory professionals learn, develop, and discover by sharing knowledge and building on each other's experience. The platform provides global access to internationally accredited laboratory-specific courses and other resources developed by lab specialists like us for the laboratory industry. LabVine is free to sign up, and you can use the link in the show notes to get started. And now for the rest of my conversation with Amanda Coble and Dr. Meriem Sefta on the People of Pathology podcast. Okay, let's talk about then, you have solutions for outcome prediction. And this is things like RlapsRisk BC for breast cancer. Tell me about these. How does this improve prognosis for patients?
So basically, RlapsRisk breast cancer focuses on early stage breast cancer patients. And in early stage breast cancer patients, you basically have three categories of patients. Patients that are obvious high risk. So the tumor is very large. There's potential local invasion of the tumor. And so oncologists and care providers will know that this is a high risk case and that they need to be particularly careful and aggressive in the therapy proposed to this patient. Some that are very low risk, obvious low risk. So for example, a tiny tumor that was caught very early, and there's features of low riskness basically. But actually today, the majority of patients fall into this middle bucket of middle risk patients where we don't really know. And in fact, only 1 out of 7 patients will in fact relapse. So it's really important to be able to, in that middle bucket, pick out the ones that are at high risk of relapse, and on the opposite side, reduce the therapeutic burden on the ones that are at low risk of relapse. And there have been some tests that have been developed in the past decade that are molecular test-based to predict risk of relapse. And we came in thinking, okay, can we better predict risk of relapse for these patients directly from that image, that digital pathology image, those 2 gigabytes of data that's systematically always there and generated for these patients. And so we trained an AI that from that diagnostic slide can predict risk of relapse for those early stage breast cancer patients. And preliminary and more advanced results have started to show that we can, in fact, better predict risk of relapse than the current standard risk tests that are used today in Europe and the US. So the idea here is to really go further than what's done today and to better identify those really high risk patients, put them on innovative therapies, refer them to expert centers, really have close follow-up with them. But on the contrary, really try to improve the quality of life for the ones that are at low risk, and they make up the majority actually of breast cancer patients. And so to make basically their follow-up and their care past the initial surgical resection of their tumor a lot better and better for their quality of life.
Okay, so it sounds like huge benefit for patients. I like that a lot. I have a family member who is a breast cancer survivor, and so this hits a little bit close to home for me. That I like this idea a lot. So there was a recently announced partnership between Proscia and Owkin, and let's talk about this a little bit. How does this partnership advance the mission of each company?
So I think it's a great match because I think we represent two sides of the same story. Proscia's platform allows basically pathologists to work in a fully digital workflow and to basically process and keep their images, their digital images, and accompanies them in this digital transformation of their workflows and their labs. And we come on top as an AI application that they can then leverage through the Proscia platform for their patients. So Proscia basically becomes door opener for us in terms of access to users for our tests because we integrate our AI solutions onto their platform. And then for Proscia, this allows Proscia to have relevant solutions that they can propose to their clients beyond the workflow platform and the digitization of their slides, but also having these AI solutions that they can easily get through the platform.
We really want to ensure that our customers have access to a broad range of tools, specifically in the precision medicine space. And we're really trying to rewire pathology for precision medicine. And Owkin is a great tangible example of a company that's doing that. And so making sure these types of tools are available to our customers, are easily available. And then even more importantly, is that they're available to patients, right? A broader range and more access to patients. So I think this is really like a perfect example of where missions align across companies, and together we're really able to make a bigger impact together.
You know, I talked to a lot of people from Proscia in this podcast so far, and it seems like that's kind of always been the mission of the company, this sort of collaboration type of thing. So this makes sense. Again, this is kind of like you both said, sort of a perfect match.
Once you start digging into how far AI can get you on digital pathology images and how powerful deep learning for this data modality can be, it kind of becomes a no-brainer first that we need to invest more in this because this is the thing that is going to unlock precision oncology at scale and precision medicine in other therapeutic areas as well. And it also becomes a no-brainer that we need to collaborate because it's such a huge opportunity that I don't think one company can tackle it all. And I actually feel like the companies that are positioning themselves right now are more allies than anything in the sense that we're kind of pushing the adoption of digital pathology at large and really showing the impact that this can have on patients. And so I really see this kind of partnership with Proscia as something that's very, very beneficial. First, commercially, but more importantly, in terms of ecosystem, really pushing the overall healthcare ecosystem's understanding of how powerful this can be for patients.
Now, whenever we're talking about AI, it's always interesting to look at the future then, like, how is this going to affect the future of the pathology field? And then what role would Owkin and Proscia play in that evolution?
I think that pathology, what's really cool is that this is allowing pathology to go from something that used to be a little bit unsexy, pathologists not in contact with patients, looking at images behind their microscope and just writing up what they see and kind of getting hounded by oncologists and their colleagues on, can you do this analysis faster? Can you count this faster? Can you tell me if my patient can benefit from this or that therapy? To, basically rewiring and changing everything and making pathology the center of a very powerful change, and basically allowing pathologists to really have the tools to pull out all the information from these images and kind of puts them back at the front and center of patient care, more so than they had in the past years. So I think that this for pathology is very, very promising. And I mean, what I've seen, at least at my level, is pathologists are always very keen to develop these AI solutions with us, go digital, transform their entire workflows and their entire way of thinking, their specialty with these digital and AI solutions in mind. And I think that the fact that they are so positive on something that is so disruptive to what they've been doing their whole life shows how much they see the potential of this for patients.
Yeah, I definitely see AI as helping, as Rare said, elevate the pathology group, the pathologists, and the care team, right? Again, you're not just the diagnostician now, you're really driving treatment decisions on another level. I'd also kind of argue that in some ways, this is also the survival of pathology. We see a lot of opportunity for automation of tedious tasks. I think we touched on that a little bit earlier. Also standardization, inter-observer variability, and even like there's been studies to show that if I do one task at 8 a.m. when I'm fresh, and I do the same task at maybe 5 p.m. as a pathologist, even the same task by the same person may not have the same exact outputs if I'm like doing my time counts, let's say. So having more standardization, and then of course the efficiency, and it actually really may be critical for just to be able to keep up with demand if we continue to see those staffing shortages. So I think there's just so much that the AI can help really drive, again, completely changing the pathology world, really.
That's an interesting point of view because a lot of times when people are talking about AI in pathology, they see it as a threat. And what you're saying is it's a benefit. It's helping the field survive and be able to handle the workload, right?
Exactly. I mean, there are these tedious tasks. And again, that goes beyond some of what we're talking about, where we're getting into these detailed insights that aren't even necessarily comprehensible by the human eye, right? But just the tedious task and some of the things that are redundant that take a lot of time, but could easily be trained to an AI, which would actually probably give more consistent and standard outputs, not just across different pathologists, but even the same pathologist, depending on the day or how tired they are. Humans are not perfect, right? And then just the efficiency gains with that as well. Then they can focus on more of the really hard stuff that they need to be doing, the harder analysis, helping build new AI, right? I see that as being critical to the future of pathology as well.
Yeah, definitely. We see exactly the same thing where I wouldn't say like survive. I would say that it really helps them evolve to match the growing needs of basically precision testing. And so the needs are growing. There are staffing shortages. So there's like more and more testing needs and stable, if not decreasing number of pathologists. And they have these images that they know are so rich because they look at them every day. And you come in with a solution saying, well, I'm going to help you digitize your images, and I'm going to help you build AI to better analyze these images. And guess what? Now you're going to become a key piece in the care of these patients, because you're not going to just be making that initial diagnosis. People are going to be turning to you and the solutions that you're implementing to better understand how to treat these patients, how to give them the best therapies for their particular tumors. And so that, like, obviously is always received, I would say, quite positively.
That's a good vision for the future. Now, I want to end with talking about interoperability. And because you've got two companies working together, and of course, your software, it has to be able to talk to each other. So tell me about how this partnership is advancing interoperability between technologies.
But I think when we hear the term interoperability all the time, and it's been a problem, quite frankly, in healthcare, not just pathology, for a long time. And I think to some extent continues to be.
Absolutely.
But I mean, having been in the lab like you did, you know what it means when you have systems that don't talk to each other. So I think, like, from a very traditional and like maybe the most basic sense, it's really just about transferring data between two systems. The problem is it doesn't always give consideration to the user experience and maybe some more standardization things. Again, as we start looking at AI and like making sure we have nice structured data, things that can better be utilized. I think that's where at Proscia, we're really focused on making sure interoperability provides a good user experience, ensuring it's more of a seamless part of the daily workflow, not something that's kind of tacked on. And now I just have like this additional system or these additional steps. So we really focus on looking at sort of the purpose and the outputs of their applications. And then we look at how do we present those outputs in the right place at the right time in the workflow, and then leverage them effectively to drive efficiency and maybe again to feed into new insights and things. So overall, like having a really good user experience. So it feels like it's just part of their typical flow. And it's not like these extra steps that make it maybe more difficult to use. We have a really robust API that is super open that we can leverage to make sure we have these really tightly aligned workflows. And then I think beyond just that technical connectivity and sort of some of the workflow pieces, we also see that it's really important to provide a seamless operations and support experience for our customers. Because if you're going to adopt solutions across different vendors, which again, no one vendor is going to have the best of breed of every single application or space. So that's where we really leverage our Proscia Ready Partner Alliance. We work with partners like Owkin, and we have sort of from sales to support, really tight operation system. And then we also want to ensure that our partner alignments are not just for today, but we also have a shared vision for the future and growth, and how are we going to continue to develop and make updates in the future. So I think we talked about the mission alignment with Owkin. I think we just see that they're like a great example of that vision we have about partnerships, being able to really dig in and find a really good workflow and have a good operational support system for as well for our customers.
Yeah, I completely agree. I would say I think that the strategic thinking where we're completely aligned with Proscia is that no one player is going to have all the AI solutions. The number of applications and use cases is just too broad. And so thinking about and designing the product and tech strategy around interoperability and being able to work together and kind of figuring that out is going to be critical to success. Us as an AI provider, we want to be able to work with third parties and be able to deploy our solutions to as many labs as possible and not lock anybody into any specific system. And I think that, on the Proscia side, you summarized quite well your kind of your strategy, your thinking about working with third parties to be able to make their solutions available at the right place and the right time to pathologist users.
Okay. I like it. This has been a very interesting conversation. I've learned quite a bit. So Dr. Meriem Sefta and Amanda Coble, thank you both very much.
Well, thank you.
Sure. Yeah, thank you, Dennis.
If you're looking for another episode of the People of Pathology podcast to check out after this one, here's a clip from the first time Amanda Coble was on the podcast, as we talk about some ways that AI can help to improve pathology workflows.
We're also going to see apps that go beyond sort of what we consider augmentation, right? Like you're improving upon workflows that already exist or things that already exist. And now we're really going to unlock completely new insights and functionality and things that were not even possible with traditional microscopy. And then that's going to really continue to advance precision medicine, especially combined with other clinical data. And I mean, to me, that is super exciting. These targeted therapies, to me, that's sort of amazing. And then the other area we're starting to see a bit on are labs wanting to actually develop their own homegrown applications for their own purposes. So those are the areas I kind of see, at least in the near term, that are going to be the biggest areas of focus for AI. But, I have a feeling there are things no one's even thought of yet, right? As we continue to unlock all the things that digital pathology can offer.
You can hear more from Amanda Coble in episode 169. Before we get into the summary, I have a disclaimer for this episode. MSIntuit CRC BRCAura BC and RlapsRisk BC are under development and not for clinical use. They are not FDA cleared or approved in the USA. BRCAura BC and RlapsRisk BC are developed within the Interoperability consortium, a French consortium financed by the government within the framework of France 2030 and the European Union Next Generation EU within the framework of the France Relance Plan. Owkin interoperability with Proscia software is for research use only, not for use in diagnostic procedures. All right, big thanks to Amanda Coble and Dr. Meriem Sefta. This conversation shed light on the growing intersection of artificial intelligence, digital pathology, and precision oncology that's beginning to reshape how we approach cancer diagnosis and treatment. We begin with the story behind Owkin, a company built on the belief that understanding complex biology requires tools beyond traditional human analysis. Dr. Sefta walked us through how Owkin emerged from a vision to harness deep learning in biomedicine, especially in oncology, and how this vision has become a reality through the development of AI-powered diagnostics. From the beginning, Owkin recognized the untapped potential of digital pathology images, not just as static visuals, but as data-rich landscapes with insights that could inform more personalized and effective care. Dr. Sefta also explained how Owkin's mission has evolved toward advancing precision oncology. At the heart of this mission is the drive to match the right treatment to the right patient. This is accomplished using AI to identify specific biomarkers and patient subgroups that might otherwise go unnoticed. Tools like MSIntuit CRC represent this shift, offering AI-driven pre-screening capabilities that can dramatically streamline microsatellite instability testing for colorectal cancer. This innovation could rule out nearly half of colorectal cancer patients from unnecessary follow-up testing, saving time, resources, and ultimately enhancing patient outcomes. That's where the partnership with Proscia comes in. Amanda Coble gave us a deep dive into how Proscia's concentric software platform can serve as the digital backbone for modern pathology labs, enabling greater efficiency and precision. The integration of Owkin's MSIntuit CRC into Concentric exemplifies how strategic partnerships can enhance both platforms, potentially bringing cutting-edge AI tools to pathology workflows and making them accessible for research use in labs across the U.S. and Europe. What's particularly exciting about this collaboration is not just the technology, but the shared vision that drives it. Both companies are committed to ensuring that digital pathology is not just a technical upgrade, but a true leap forward in patient care. With interoperability and scalability at the forefront, Proscia and Owkin are working to ensure that these innovations are not siloed, but connected, creating an ecosystem where AI, data, and human expertise converge seamlessly. As we emphasize, AI isn't here to replace pathologists. Instead, it's augmenting their role, helping them make more informed decisions faster and with greater confidence. It's about freeing up their time from routine or manual processes and allowing them to focus on what matters most, providing accurate diagnoses and guiding treatment decisions that can change lives. Amanda even mentioned how AI might help to protect pathology, allowing the field to move to the forefront of patient care, where it should be. So, what does all of this mean for the future of pathology? It means we're standing at the threshold of a transformative moment. With AI-driven tools enhancing diagnostic accuracy, streamlining workflows, and offering new levels of insight into disease biology, pathologists can be better equipped than ever to play a central role in precision medicine. As digital platforms continue to evolve, and as collaborations like this one push boundaries, we're witnessing the emergence of a pathology field that is faster, smarter, and provides better patient care. As always, I'll have links in the show notes to everything that we talked about today. Don't forget you can follow the show at People of Path on Instagram and Twitter, or just connect with me on LinkedIn. Thank you for continuing to share the show with others. Together, let's inspire the next generation of pathologists and laboratory professionals. This show is a member of Health Podcast Network. Thanks for listening. I'm Dennis Strank, and I'll talk to you next time on the People of Pathology podcast.